Application of differentiation. An example, the motion of a particle is given by s equals to e raised to power minus t sine of 2t, where s is the displacement from the mean position at time t. Roman 1, you have been asked to show that the maximum value of s occurs when t equal to 0.5536. And Roman 2, we have been asked to determine the displacement and acceleration at this time. So solution, since the function of s is given by e raised to power minus t sine 2t. So this is application of differentiation, whereby at maximum, show that the maximum value of s occurs when t equals to this. So at maximum velocity, we can say at maximum displacement, then our velocity should be what? 0. At maximum velocity displacement, so when s is maximum, then velocity should be what? Should be 0. Therefore, since the function of s equals to e minus t sine 2t, therefore ds dt, this change in displacement over time, that is what? This is the velocity, which should be 0. Now, how can we get our ds? So our velocity is just the derivative of this one. So you take the derivative of this multiplied by this. Derivative of that one is just minus e raised to power t. Then we multiply by sine 2t. Then plus the derivative of sine 2t, whereby the derivative of that one, it will be so the derivative of sine 2t is just 2 sine 2t multiplied by e raised to power minus t. Now let's come and simplify this expression. So v equals to what? E minus e raised to power minus t sine 2t plus e raised to power minus t should be 2e sine of what? 2t. Therefore, this you can equate this function to be 0. So plus 2e raised to power minus t sine 2t is equals to 0. So we can see that we have sine of 2t, and we have minus et, No. The derivative of sine 2t should be 2 cos. Should be cos. Derivative, when we differentiate sine of theta, it just give you cos of theta. So it should be cos. So I'm sorry, here should be cos, and here should also be cos. But sine 2t is the same as we write as 2, because double angle is 2 cos t sine t. Then plus 2e raised to power minus t cos 2t, which is equals to 0. Therefore, minus e raised to power, so it will be minus 2e minus 2e raised power t cos t sin t, then plus 2e raised power minus t cos 2t is given by 0. But we have to write cos 2t in a well and good form, since this is 2t and we're only interested with 1t. So cos 2t also, so minus 2 raised by minus t cos t sin t plus 2e per minus t. This is the same as cos squared t, then minus sin squared t, which equals to 0. Finally, let's just open the bracket. So minus 2e raised by t cos t sin t is given by what? So 2e raised by minus t cos squared t minus so it will be let's write it as minus sin squared t, which equals to 0. But cos squared, there is cos squared t and sin squared t, but we know that cos squared t is the same as what? So minus 2e raised by minus t cos t sin t. This should be plus, so plus 2e raised by minus t. This is just 1 minus sin squared t, then minus sin squared t. So it should give us 0. So it should give us 0. Therefore, minus 2e raised by minus t cos t sin t plus, so just 2e raised by minus t into 1 minus 2 sin squared t equals to 0. Opening the brackets here, it will be 2 minus e raised by t cos t sin t plus 2e raised by minus t minus 4. So it will be 4 minus 4 e raised by minus t sin squared of t equals to 0. So we have to take this one, because take this one to the other side of 0. So taking 2e raised by minus t to the other side, therefore this it will be 2e raised by minus t cos t sin t plus 4e raised by minus t sin squared of t will be equals to what? 2e raised by minus t. So you may be asking yourself why the signs have turned positive. That's because when you take this one to the other side, therefore it will be minus, but dividing both sides by negative sign, the end result will be positive sign. So far we are here, but you can see that e is in each and every element. Therefore you can just divide both sides by e and they cancel out. So e, they'll cancel out in both cases. Also 2 can cancel out in both cases. Here it will be 1, here it will remain 2, here it will just remain 2. And we can also factor for sin t, because sin t here is here and sin t you can find it there. So factoring for sin t, this one they'll cancel out, divided by 2e raised by minus t both sides. Here it will cancel out, it remains sin t into cos t, then plus here it will remain only 2, it will remain 1 sin t equals to what? 1. This one will cancel out. So setting sin t equals to b. Therefore, drawing a triangle. So setting this one to be our angle t, therefore our angle should be opposite b over 1. So our adjacent will be just 1 squared minus b squared. That is our adjacent. So sin t equals to b. So wherever we have sin t, just place it will be into our cos. It will be cos t is just adjacent of hypotenuse, which is just root of 1 minus b squared. So we should write plus. So our sin t equals to b. We have set it to b. Therefore, our cos t, it will be just adjacent of our hypotenuse, which is root of 1 minus b, then plus 2 sin t, which is 2b. Our sin is b. So this one, it will give us 1. Therefore, our b, root 1 minus b squared, plus b times b to b, 2b squared, equals to what? 1. For we to eliminate the root, we have to square both sides. So we square each and every element. Or before squaring, we can just take this to the other first. We should not square, but take this one to the other side, which it will be b, the square root of 1 minus b squared, which equals to 1 minus 2b squared. So we can divide by b, so that it will be root of 1 minus b squared, which equals to 1 minus 2b squared. So all over b. Then we can now square and square, so that it remains 1 minus b squared, which it will be what? 1 squared minus 2. This times this one, which is 4b squared, then plus c squared, which is 4b raised by 4 all over b squared. But multiplying by b squared, here it will cancel out, and we will remain with what? B squared minus b raised by 4. B squared minus b raised by 4, multiply both sides by that one, then equals to what? 1 minus 4b squared plus 4b raised by 4. So just take these two to the other side. We can see this is minus, when it goes there it will be plus, and this one is positive when it goes there to be negative. Therefore, it will be 1 minus, so minus 4b minus 1b to be minus 5b squared, then minus b raised by 4 plus, when it goes there it will be plus, so plus 4b plus b, it will be plus 5b raised by 4. So this one should give us 0. So we can write this one in quadratic form, which is 5b raised by 4 minus 5b squared, so plus 1, which equals to 0. So we can see now this is a quadratic equation, but we have to setting b squared so as it can be, we can solve it using the quadratic formula. Just set b squared to be something like q, so when you substitute there with b squared, it will be 5q squared minus 5q, so plus 1 equals to 0. So using the quadratic formula, so minus b plus or minus the square root of b squared minus 4ac all over 2a should give us the value of q. So minus b, so it will be 5 plus or minus the square root of b squared. So the square root of b squared is 25, minus 4 multiplied by 5, which is 20, multiplied by c. So 4 multiplied by 5 which is 20, so minus 20 all over 2 multiplied by a, which is 10. Therefore 5 plus or minus the square root of 5 all over what? All over 10. So this is our result, but the square root of 5 is almost 2 point something. So using our calculator to evaluate that, see, the square root of 5 is 2.236. Therefore 5 plus or minus 2.236 all over 10 should give us the value of b. So 5 plus 2.36 over 10 should give us the value of b, or 5 minus 2.236 over 10 should give us the value of q, not b but q. We are looking the value of q. So getting q, just 5 minus 2.36 over 10, or 5 plus 2.236 over 10. So using your calculator, when you key in this, the calculator will display this answer, and when you key in this result, it will display this answer. So you will equate to q. So q can be obtained by this or this one. So getting q, but q equals to b squared. Since q is b squared, meaning getting b is just the square root of q. So square root of q, we get our b. So our b is either 0.8506 or 0.5257. But sin t, we set sin t equals to b earlier. We set sine of t being b earlier. Therefore, so sine of t equals to 0. We have b equals 0.8 and 0.5. So these one are our b's. So t is just sine inverse of this, or this one, which is here. So keying in sine inverse of 0.8506, it will give 1.0171, or keying in sine inverse of that one to give 0.55354. Therefore, we can see our question. Our first question was asking to show that the maximum value of a's occur when t equals to 0.536, which is here 0.55354. So therefore we have shown that t occurs either in this time or this time. So we have shown it's being